So hi, my name is Katie. I work at Planning Center. I'm a developer here. I've been here for about 2.5 years. Pretty cool. Mostly decent people, mostly. No.
Tell us about the bad ones. Tell us about the bad one.
I was going to say, they're all here. So tonight I'm going to talk about 5 Ruby methods I didn't know I needed and maybe still don't. So Ruby gives us a ton of really cool, neat little things for free that I don't really know much about. So I thought that this would be fun to kind of dig in and learn things, and hopefully it'll be good for you guys too. Let's go. So my first one I'm going to talk about is chunk while. It's called on an enumerable, and it takes in 2 arguments, the current and previous elements, and compares them to decide when to start a group, specifically when the condition is no longer met. So if we look at the array that I have, it's just an array of random numbers. What I want is to group it by even numbers and odd numbers. So I call chunk while, and I pass it a conditional a even equals b even. So if we look at 1 and 5, comparing 1 and 5, 1 is not even, so it returns false, and then 5 is not even, so it returns false. Conditional is true, so we don't chunk. So we go on to 5 and 2. 5's odd, so it's false. 2's even, so it's true, and so the conditional is no longer even, and we chunk. And it goes like that throughout the array, and that's how we get our chunks. It has a sister method called slice when, which does pretty much the same thing, but they differ on how they decide when to chunk. So you can kind of hear it in the name, where slice when slices when the condition is true, chunk while continues to chunk while it's true. So if we did the same thing but with slice when, and we use the same conditional and wanted the same results, it would end horribly. So now we're using slice when on the same array. We're asking if A is even and B is even. So comparing 1 and 5 again, 1 is odd, 5 is odd. So that's true, and we slice then, because we're slicing on the true. And then we go to 5 and 2, 5's odd, 2's even, that's true, and we don't slice. So we get the exact opposite of what we wanted, which is less than ideal. So in order to get our groups of odd and groups of even numbers back, we'd have to say slice when A does not equal B even, which is confusing. Because what you really want is chunks of numbers that are all odd or all even, and throwing in a not in there makes it difficult to see that at first glance. So what I really like about chunk while is that you can be more honest about what you're really asking for, and 2 months down the line, when we're 2 beers in trying to decode or debug this, it's a little bit more clear what we really want to say. So do your future self a favor and say what you really mean. Use chunk while. And on to number 2, repeated permutation. So it is called on an array and takes an argument which determines the length of the permutations that are returned. And then it will return all possible permutations that can be made with those values. So if we look at the example, I have an array of 3 numbers, and I pass 2 into it. So array repeated permutation 2. I get back 9 permutations with 2 values in each. The amount of permutations you get back will be the original array length. So right now 3 raised to the nth power, which is 2. So in this case, 3 raised to the 2nd power, or 3 squared, is 9. And you can imagine how quickly that would snowball out of hand. And repeated permutation is a close relative of permutation, combination, and repeated combination. I know, it's a lot of big words. So to kind of touch on them a little bit, combination doesn't care about the order of things. So right now we have a 1 and 2 and a 2 and 1. Combination wouldn't give you back the 2 and 1. It would only care about the 1 and 2. It also wouldn't let you repeat numbers. So the 1, 1, 2, 2, and 3, 3 would not be there for the combination. For the permutation, a little bit better, but not quite. So we don't care about order. We'd get 1, 2, and 2, 1. But we still can't have the 1, 1, 2, 2, and 3, 3. So then we get repeated combination. So same as combination, but we get back the 1, 1, 2, 2, 3, 3, but we still don't get the 2, 1, and 1, 2. And that's where repeated permutation comes in, and we get them all. So we get the 1, 1, 2, 2, and 1, 2, 2, 1, which is fun. So yeah. So kind of a little interesting, fun thing. If you call the original array, which has 3 numbers in it, if you call permutation 4, so you want a permutation of 4 with 3 numbers, and you can't repeat any numbers, you're going to get an empty array, because that's not possible. But if you did the same thing with repeated permutation and called 4, you'd get 81 different permutations back. Yay! Because why not? Okay, number 3. Now for member. So this one was interesting. When I was looking for the 5 methods I wanted to talk about, I wanted to do ones that I haven't used before and I haven't seen and were interesting. So I went through the docs and I saw member and I'm like, I have never seen this in my entire life. What is this? And I looked at it real quick and it seemed kind of interesting. I was like, sure, I'll throw that in the list. We'll look at it. We'll look at it. And as I was doing more research for all the other methods, I couldn't really find anything on member, like anywhere, which was real annoying. And I was like, I can't believe no one's ever talked about member ever, until I looked into the actual docs. And it's really similar to something that I use all the time. So I don't know if any of you guys use include, but I use it quite often. And it's kind of similar to what member does. So it looks through the array. Yeah, it'll look through the array to see if the element is present. If it's true, if it is, it returns true. If it doesn't, find the element, it returns false. So literally exactly like include. If you dig down deeper, they're like really, really similar. So the only thing I could find that was different between member and include on array is that member was not redefined on array, so it's slightly less performant than include. So if you want a slightly less performant include, you can use member. You can use member. Just in case you were looking for that, I found it. Don't worry. Found it. Perfect. Okay, on to number 4, minmax. This one was one of my favorites. So I found minmax a while ago. I was on Code Wars. I don't know if you guys have heard of that, but I'm going to touch on it a little bit. But it's a bunch of different little coding challenges that you can do. I think they do 46 different languages, and the skill set is from very beginner, never looked at this language before, to senior, which is pretty cool, pretty widespread. And they're just little tiny challenges that you can do and just stretch your brain a little bit. But what I really love about Code Wars is that once you finish your challenge, you submit it, make all the tests pass, perfect, you can see how everyone else solved that problem. So, and you can sort all the solutions either by best practice or most clever, which is always a fun one, because then you find all the fun little methods like this that you never knew happened. So I was doing a Code Wars challenge. I had to find the min and max of an array. And I did some crazy loop and some unnecessary things, but it passed, ship it, it's fine, perfect, love it. And so I got to where I could see everyone else's code, and I went to the clever, and one person had just a 1-line array.minmax, and I'm like, you kidding me? It's really, yeah, so I was a little bit crushed, but then also I fell in love a little bit, so so min-max is pretty straightforward. As long as all the elements in your array implement comparable, you can call it without a block. So just min-max and you're good to go. It'll return a 2-value array with the min and max elements. Min will be at 0, max will be at 1. If all of your elements don't implement comparable, you can pass it in a block and tell it how you want to decide which is min and which is max. Or you can use min-max by and pass the value you would like to compare, and it just does that for you straight away. So if we look at the example, I have an array of strings, and if I just call min-max, nothing else, it compares them alphabetically. So by is my min and high is my max. But if I wanted to compare them by length instead of alphabetically, I can just do array min-max by, pass it in length, and then I get high as my min and goodbye as my max. And if for whatever crazy reason I wanted the max in 0 spot and min in 1 spot, I just flip it with the block, and yeah, I get goodbye and high. So yeah, because why not? I can. All right, we made it. The last one. This one's a fun one. String unpack. So what is it? What does it do? Quite honestly, I'm still not 100% sure, but we're here, so we're going. So the formal definition is that when it's called on a string, which may contain binary data, it decodes it according to the format string, returning an array of each value extracted. Cool. It also has a sister method called pack that is called on an array and uses a format string to turn the elements back into a string. Cool. So if we look at the sample that I put up there, we have a string hi there, and I can call unpack and pass it in a capital B. That's binary most significant bit. And if I pass it in 1, I get the first most significant bit. If I want 2 of them, I can do B space B, and it'll space it out for me. If I do B, B, B without a space, I just get them all smushed. So whatever you would like. If you want all of them, you can just add an asterisk at the end, and you get all of them. If for some reason you wanted the first 4 in most significant bit and the last 4 in least significant bit, you can pass it capital B4 space lowercase b4, and you get that. So the format string is made up of directives, and there are 42 different ones you can choose from. 42. Why? I don't know. But you can mix all of those. If you wanted to mix a binary and a hex and whatever else there is, you are free to do so. Yeah. No lowercase c. No, none for you. And while unpack will always return an array of values, depending on what directive you use in your format string, the values in your array can be integers, floats, or strings. So it's real fun. So honestly, if you guys have any real world use case for this, help me out, because I can't figure it out. I want to be able to use this, but I can't. The only thing I asked around, maybe if you were trying to do your own binary to hex to decimal converter, or you wanted to do your own encoding and decoding for fun, because things. But yeah, other than that, I got nothing. So if you think of something.
Like with interfacing like Raspberry Pi with hardware.
Oh, there you go. Thank you, Gio. Oh. God?
Raspberry Pi using hardware.
Oh, for Raspberry Pi, using hardware, trying to manipulate everything like that. Yes. That's my mentor. But yeah, those are my 5 methods that I decided to talk about. Also, Code Wars, check it out. It's really fun. And yeah, thanks for listening to me talk for like 12 minutes. Yay!